Hello, everybody, and welcome to another stream here. We are here with the Forta Foundation, Christian and Andy, who are going to be teaching us about the Forta protocol, what it is, and why it's so important. As we all know, security is essential in Web3, and we don't often talk nearly enough about monitoring. When it's these monitoring tools, these monitoring of our decentralized protocols that can be the secret sauce to preventing hacks, to keeping us secure, and keeping us where we want to be. Andy and Christian, what is Forta? Tell us about Forta.
Thanks, Patrick. So I've got a few slides here I'm going to walk the listeners through. So I think for any audience, technical or non-technical, I think one of the best ways to think about the Forta network is like a giant security camera and alarm system for Web3 that sits above layer ones and layer twos, and it looks down on all that on-chain activity, and it's watching in real time for suspicious activity. And you can see on the screen there the logos for the chains that Forta currently monitors. So right now, the 7 largest EVM chains, so Ethereum, Polygon, BNB Chain, Avalanche, Optimism, Arbitrum, and Phantom. And it's under the hood, it's actually a combination of over 1,100 little security cameras that we call detection bots. And for everyone watching, if it wasn't clear what those little icons are on the screen, those are supposed to be cameras pointed down. I hope that's clear. So it's actually 1,100 of these little cameras. So when we call it a network, it's a network of these cameras that we call detection bots. And what are these detection bots doing? Each one of them is watching for something different on chain. And here's a sense for what the footprint of the network looks like today. So you'll see a bot count on the far right there and assigned to one of the 7 chains that we are monitoring today. And then we also have a node component too. Our detection bots, our security cameras, are actually run by these node operators behind the scenes. So they're the ones doing the work, keeping these cameras running 24/7, 365 days a year so that we don't miss anything suspicious happening on chain.
On Ethereum here, we're saying there's 2,200 Forta nodes, if you will, and each node is running 434 different bots.
So there's 434 total security cameras / bots that are currently watching Ethereum mainnet, and those are being run redundantly by 2,214 Forta scan nodes.
So every single one of these scan nodes is running like this bot, this script as well. Okay.
Exactly. Yep. So practically what would happen, and Christian might talk a little bit more about this when he gets into to the bot development piece a little bit later, but each camera is actually run redundantly on the network. So there may be six sort of identical copies of that camera being run by different nodes. That way, if one of those cameras goes down, there's still 5 other cameras that are going to catch that activity.
Wait, so sorry, did I miss that? So on the ETH network there, one of those bots might only have a redundancy of up to 6?
Correct. Yep.
Okay. So the bots are opt-in, and then maybe I'm jumping ahead a little bit here.
Practically, the way it would work, let's say Christian publishes his bot on the Forta network. He can choose how many sort of times he wants that bot replicated across the network. So if you just want it to run once, it can run once, but you don't have any redundancy at that point. If you want it to run 6 times or 10 times across 6 or 10 nodes respectively, you can do that. The redundancy is opt-in, developer choice. Yep.
Interesting. So in order to run one of these bots, you have to be one of the nodes. And let's say I'm the bot developer and I go, I want 10 nodes running my bot. Is there like a fight for who gets to be one of those nodes running the bot? Because I'm assuming there was a reward mechanism for running one of these bots. How do you select those 10?
It's a great question. Easy solution. Bots are randomly assigned to node operators. We have an assignment mechanism in the protocol. And so bot developers do not get to choose which node runners run their bots and vice versa. Node runners have no say in which bots they're assigned either.
Interesting. All right.
Because Forta is a permissionless network, as I mentioned, any developer can publish one of these bots. A lot of them are monitoring for threats now. And so tried to carve out here visually a percentage of cameras on the network that are actually detecting threats and other malicious activity in real time. And I think the unique thing about Forta and what differentiates it from other projects in the space that also focus on monitoring is just this sort of decentralized, permissionless, kind of community-based approach to threat monitoring and detection. So just to give you some examples, there might be a bot on the network that detects phishing attacks that is developed and maintained by the Forta Foundation. So that blue bot on the screen could be something that Christian has developed and maintained, for example. There may be another one that detects smart contract exploits, and this one's maintained by a separate security team altogether, like a BlockSec, for example.
Is BlockSec running one of these?
Yep, I was going to say these are all real examples. BlockSec does have at least one bot running on the network, and they are in fact detecting smart contract exploits.
So can I ask about that too? Because I've seen BlockSec post some tweet threads about them blocking malicious transactions. So if they're running one of these bots on Forta, does the bot developer get to run their own bot, I guess, is my first question there. So let's say BlockSec creates one. Do they get randomly assigned? I know you said like the bots get randomly assigned, but do I get to run my own bot or no?
You do not run your own bot. And it's an interesting point you bring up. So the vast majority of bot developers, of these devs that are building these little cameras, are not node runners. They're two distinct groups of stakeholders on the network. The developers are building the bots. The node runners are the infrastructure under the hood that keeps the bots running 24/7. And 99% of the time, they are different people and teams doing those jobs.
So can I ask, and maybe you don't have the answer here. So I've seen a number of BlockSec tweet threads where they detect some type of malicious activity going on. They block a transaction. If they develop the bot, but they're not running the bot, I would assume maybe they're just running it themselves, and then they try to front run the Forta network to be the first one to get the glory of saving the protocol. Is that something that you guys have thought about, or maybe I'm digging too much in the weeds here? What are your thoughts on that?
No, I think it's another good question. I think what I'll say here is that I know a team like BlockSec, which is, I think Christian and I view them as one of the leaders in the Web3 security space, have historically done a lot of mempool monitoring in particular to try and detect things as early as possible and then front them as a white hat, right? And then be in a position to return those funds to a protocol. The way that BlockSec is using Forta today is they've created one of these detection bots that is emitting public alerts about things that they are seeing happen on chain. So it's not necessarily about them front running the Forta network, for example. It's more about them using the Forta network to socialize more broadly when they detect these things, because alerts on Forta by default are public today. And that was by design, which I guess gets to another interesting point here, which is that all these cameras that you see here on the screen are constantly emitting intelligence, right? Think about a security guard in a booth watching a video screen 24/7, right? That's effectively what's happening virtually on the network, right? These cameras are emitting intel all the time. In some cases, people are watching. In other cases, people aren't watching. But BlockSec has a really valuable camera that they've developed. And there are many teams that are watching BlockSec's FortaBot because they can consume that intel.
So there's a lot of teams watching BlockSec's FortaBot. Is it, I guess we're getting into very specific implementation here.
That's a good question.
If they said, hey, I want to be the only one to run this, or no, they can't do that. Okay. So if they say they want a redundancy of like 5, everyone's just watching those 5 nodes that have got assigned to their bot.
You don't need to watch specific instances of the bot. Let me get into kind of the user experience a little bit.
Sure.
Patrick, let's say that you're interested in getting the alerts that are generated by BlockSec's smart contract exploit bot. What you can do through the Forta app is you can actually just subscribe to their bot. So it's like tapping into the security camera feed live, and you will get alerts pushed to you in real time anytime the BlockSec bot finds something.
Got it.
And so that's practically how most users are interacting with something like this today. Is they hit subscribe, They enter their email or their Telegram channel webhook or something else, and the Forta network is sending them those alerts in real time as they happen.
If I'm a bot developer, or but yeah, let's say I've come up with some crazy, amazing monitoring solution, right? It almost sounds like this is the battle a bot developer will have to go through. If they have a big enough following, maybe like BlockSec, maybe they decide I could push this onto Forta, or I could charge $1,500 a month for people to get access to this feed. Is that something that like bot developers looking at? Hey, like I could put this on Forta and then socialize the gains, or I could privatize the gains. Is that something that you've run into?
Yeah, it's a great question. Let me jump forward.
I'm derailing your whole presentation here.
No, I think it's a great question. I'm totally fine hopping around here. Our vision is for these bots to monetize the intelligence that they generate. So you can think about each of these little cameras like a microservice that, is providing some value to some amount of people, and those people might be willing to pay for that data. Our community recently approved a governance proposal to turn on fees on the network. So up to this point, for the last 18 months, publishing a bot on Forta and consuming any of the data that's being generated by the network has been free. In roughly a month, we will turn on fees, and teams like BlockSec and others will have the ability to monetize their detection bots. And the goal is long-term is for an intel marketplace to develop where you have many high-value, high-precision bots that are actively maintained by respected, reputable teams in the space or individuals. And there, on the other side of the marketplace, there are both individuals and there are other teams and there are other bots that want access to that data and are willing to pay for it. And this is something that we should see start to scale starting around August when we turn on fees.
Nice. Okay, cool. So the game almost from the Forta Foundation perspective is, okay, how do we make it so that the monetary gain of the bot developers is greater than what they could do on their own, which makes sense actually at the same time, because if you have this one-stop shop for monitoring, which is the Forta network, then it becomes a lot easier for bot developers to be incentivized there. Interesting.
That's right.
Cool.
Yeah, I think the value for a bot developer, if a bot developer is watching this and thinking about the question that you just posed, right? Should I do this myself or should I develop it on Forta? Some of the advantages that we can provide are we give you a bunch of infrastructure that you get to leverage, right? You get as much redundancy as you want. You get a decentralized network. You also get the benefit of sort of all the user tools and UIs that we've built that make it easy for people to find what you've built. And then there's an existing sort of user base around Forta, which I think is the value of selling anything on a marketplace, frankly, right? Is that you're selling into an existing user base. So we're hopeful that the revenue opportunity of selling something on Forta is greater than having to do it yourself and manage all of those things internally.
Yep, makes sense. All right, we can go back to where you were.
Okay. So I just had a couple more things to get through as part of this intro. I think at this point, we've established that there's a variety of individuals and teams that have developed different types of bots on the network. And I just wanted to show another example of kind of what's possible here. So something else that we have started to do recently is starting to compose these bots. So in the spirit of DeFi and composability, the same sort of concept can be applied to monitoring. So we have special bots that are running on the network. Any developer can also build one of these. They don't actually listen to on-chain activity at all. They just listen to alerts from other bots. And so you can think about it as composable monitoring, or you can think about it as like hierarchical monitoring. But we have a few examples of this, and it's proven to be very effective detecting things like scams, so phishing attacks and address poisoning and rug pulls. And there's a whole sort of category of scams that are really impacting end users today. And packaging up all of those in one bot is actually really useful for wallets and exchanges that want that intel so that they can then use it to protect their user base. So I think Christian and I are really excited that we'll see more of this composable monitoring from other teams in the future, because I think it expands the design space for bot developers. You get to leverage everything else that people have built on the network.
Like conditional logic for alerts. That makes sense. Can I ask another side question, actually? What is to prevent me from saying, all right, I'm going to build a Forta bot and I want 2,000 redundancies. So I want every node on the network to run this bot. And my friend Jerry, I don't like him. So I want all these bots to spam Jerry. Is that something that I could do on the Forta network? Well, basically, like instead of doing good person behavior, you do bad person behavior.
Sure. Yeah, there is. So I guess to address your first question, there is some practical limit imposed on the amount of redundancy. We obviously don't want every developer to say, I want all 4,600 nodes on the network to run my bot. I think to go back to that point we were talking about earlier, I think the default right now is 6. It is possible to go higher, but it's also very easy for us to impose an arbitrary threshold there to prevent someone from just spamming their bot across the network. So that was hopefully address your first question. The second one, with respect to quality control and spam mitigation, we have a couple different levers. The primary one is that bot developers are required to stake on their bots. We don't look at this like a fee necessarily, because you can get it back. It's more of you're posting a bond that's saying, my bot is a legitimate bot. It's not spam. And there are mechanisms in place for you to forfeit that if you did something that was malicious, for example. So staking is in place to hopefully mitigate spam activity, like you said.
So what's the mechanism that blocks me from doing that, though? So great. So I say, all right, cool. I'm going to put up whatever. Let's say it's $100 worth of Fort to stake. I put up $100. I go, cool. In my mind, I go, great. I just need to pay $100 to get like a pseudo botnet army to spam Jerry. What's going to stop that from happening?
The good thing is that Jerry doesn't need or isn't forced to consume your bot's activity, right? So if, let's say, I were to publish a bot that was really spammy and noisy.
Oh, I meant more like, not so much like alerts. Like, can my bot make like HTTPS get or post requests? I'm assuming it can. Right? So if I can do that, I can build a bot that makes a whole bunch of post requests let's say I know Jerry's IP, and I just start slamming Jerry's IP with a bunch of random nonsense. And I go, cool, had to pay $100 or had to stake $100 for that. I don't care, whatever. What's the mechanism? Like, how quickly would I get shut down? Is Jerry doomed? Is Jerry doomed?
Yeah, we do. There is monitoring in place to detect what I'll call sort of anomalous bot activity. And it is possible to penalize a stake, but to your point, right, pointed out the fact that the stake it's a fairly small amount of capital. And so that might not be the best. That might not disincentivize someone enough to do it. But it is possible to see a bot engaging in activity like that. I should point out that there are also bots that are very legitimate that are also high resource intensive bots. And so on their face, they might look similar in the way that they behave. And so it really is a case by case basis.
Sure.
On very few occasions, we've had to take action against a specific bot. This was largely in the early days of the network when we had a little bit more sort of centralized control over things. Practically, what would happen today is in theory, like a node could also just take itself down, right, if it was being burdened by running this particular bot.
Can you veto a bot if you get assigned? Oh, like I got assigned to the spam bot. I don't want it.
It's a good question, and it's actually an interesting sort of feature that at some point in the future may be added to the network. Currently, node operators do not have any say over the bots that they run. However, sometimes you'll get a bot that is assigned to a low reliability node runner, right? Who their uptime isn't particularly high, which impacts the bot's performance. And so what will usually happen in those cases is that the network will pick up on the fact that this particular node or group of nodes is not performing as expected, and that bot will get automatically rotated to other bots on the network. So another way to think about it is that if a node runner does not do the job that they're expected to do, they lose the opportunity to do that job going forward.
Sure. So there's no way though for like the Forta network to vote out a bot. If I build a bot, I stake it, it's up.
Currently no ability to vote out a bot. I'm sure there are a few levers that the core dev team though could take in extreme situations, but there's no way for the community of Fort token holders, for example, to veto a bot, at least at this stage.
I thought that was different. I thought there's essentially the opportunity to create a slashing proposal that then gets acted on by the council to slash a particular bot, which if essentially without a stake, they would essentially be removed from the network.
Okay. Yeah. Christian brings up a great point. So yeah, I think we have a slashing process. And as he said, the result of a slashing process is that you would have no stake.
Right.
And if a bot has no stake, it becomes inactive. So yeah, I think that's a great point. We have an indirect way of doing it.
Is that live right now?
Slashing is live. Yep.
So is that like a voting process? So if I'm a malicious user, network has a slashing thing to prevent that. How does that get enacted? How does the slashing work?
So anybody can basically submit a slashing proposal on the governance forum. And then there's the council that will review. The council essentially consists of members of the Forta community that then will review that slashing proposal, will review the bot, will review the evidence, and then it either gets approved or rejected based on that evidence.
Got it. Cool. Summary here, if I decide to spam Jerry, somebody could put up a slashing governance proposal, stop me from spamming Jerry. Cool.
That's true, Patrick. I would say, as Andy kind of mentioned, in the early days where we did not have staking, we did see bad bots, spammy bots. But as soon as staking was introduced, and the amount of stake is really not that big, it immediately has disincentivized folks that kind of that way.
So we've seen though in the industry, the stake lost has to be greater than the amount gained from the spamming. Like we saw one of my favorite, but like least favorite instances was somebody staked like $175 worth of Teller, changed the Oracle price of a protocol that was relying on the Oracle price and ended up stealing like $100 million or something like that.
Yeah.
So they're like, all right, cool. I lost $175 and gained 100 million, or maybe it was like 20 million or something. I forget. It was a big number, but interesting in any case. So thank you for the clarification. That makes sense. The crypto economic games that we play are very tricky, and I'm always very curious how people have implemented it. And everyone's always working to improve them anyway. So,
hey, Patrick, maybe to give folks watching a sense of the ecosystem of
nice
users and bot developers looks like. Yeah. So this is a sample of Forta's user base today. Some of these teams are developing their own bots on Forta and using them to monitor their own contracts. So teams like Compound, Maker, Lido, Phantom even does this for some internal monitoring. And then you've got teams like BlockSec and Halborn who are also maintaining their own bots that are more threat specific. And then there are teams like Zengo Wallet, Solidus Labs, which is a compliance platform, that are just consumers of the threat intel that's generated by some of these bots. So there is already a really budding two-sided marketplace here. Some of these teams are both developers and consumers. And then we also have just developers and we have just consumers. And so it's been really exciting to see what teams that are represented here on the screen are building. And we hope we can add a lot more going forward.
Cool.
Okay. That was that's what I wanted to get through for a high level, non-technical. If you had any other questions about anything we covered or anything I didn't cover, I'm happy to field that now.
Sure. Yeah, this is great. So these are, when I spin up a Forta node, and then maybe this will be what Christian goes over to. When I spin up a Forta node, it's doing similar stuff to a blockchain node, without actually having a ledger, right?
It's just a piece of software that is running the code that's inside of the Docker container, which is really what a bot is.
So if I'm running a Forta node, is that my Forta node? I'm assuming my Forta node is talking to other Forta nodes. No, it's not talking to other Forta nodes. So how does my Forta node know who is keeping track of the bots? Let's say there's a bot that needs 6 nodes running. How does my Forta node know that?
Your node doesn't need to know how many it's running on, but the Forta system knows. And so each Forta node sort of communicating with the assigner that it gets its tasks.
So who's the assigner?
That's one of the components of Forta protocol. Yeah, one of the sort of primary system components is the assigning mechanism that kind of takes in all the newly published bots and then randomly assigns them out to active node runners.
Right, but I felt Christian chomping at the bit to kind of go into that a little bit more. But who's doing that, right? If it's a permissionless network, my initial thought was, okay, every node is talking to each other. They're keeping track of each other. But now it sounds like there's like a centralized assigner.
Well, the centralized components they're really not centralized. They're essentially smart contracts on the Polygon network.
Okay.
And essentially, a node is able to talk to those smart contracts and basically say, hey, what bot should I download? What bot should I run? And then they essentially get that information from the smart contract.
Okay, so
when I deploy a bot to the network, I actually register it with the smart contract deployed.
Okay. Got it. Makes sense. So I register the bots. I obviously don't register the nodes then, because if I were to have to register nodes, that would sound like a horribly gas intensive process. But if I spin up a node, do I have to register it on the smart contract too?
Yes, otherwise you wouldn't know that there is a node available that is able to essentially take work.
Gotcha. Oh, okay. So that's actually probably better than another thing about it. Originally, I was like, oh, that sounds awful, because if I want to spin up a node and spin down a node, but it actually incentivizes me to not spin up and spin down nodes all the time. Okay, that makes sense. So the smart contract network, all the nodes, all the Docker containers are basically reading off of this smart contract, and that's how they know what to do. Okay. So I could hypothetically just run all this stuff myself, but is the smart contract keeping track of who it's given jobs to? Do I have to send a transaction to accept a bot?
The smart contract keeps track of what bots are assigned to what nodes.
So smart contract keeps track of, okay, so that's how the payment will work, because the smart contract has all of that up. Got it, makes sense. So I could hypothetically run all the bots on the network, but I just wouldn't get paid anything because the smart contract says cool, but we didn't assign you that one. Got it. Cool. Yeah, I think this makes sense. Yeah, thank you for the introduction there, Andy. That was great. Looking forward to seeing it now.
That's right. So we'll jump into, and Andy kind of talked about the marketplace that is about to get launched and the introduction of fees. And so the example that I have picked is, what if you want to be participating in this marketplace and develop essentially a valuable bot on the network? And then this example is also a modular example that is building on top of the existing kind of threat intelligence and the bots that are deployed on the network. So it doesn't really start from scratch. So I have a slide deck as well to frame this a little bit, and then we'll jump into, let's see here, no multi-screen, so it's always a little challenging, but I think there we go.
All good, all good.
I think you're able to see that now, right?
Yep.
All right, so let's just review what a Forta detection bot is. A detection bot is essentially a heuristic or a machine learning model that takes a set of transactions, blocks, from the blockchain, depending on kind of what blockchain your scale node is monitoring, right? Forwards it onto your detection bot. It processes that information and then essentially emits an alert or a label. A detection bot can also subscribe to alerts and labels that are generated from other bots to create that modular system that Andy was talking about. Now, you may want to ask, what's the difference between alerts and labels? The way I think about it, alerts is really information about behavior observed in real time. So I think about, hey, there's a transaction that is clearly a ice phishing attack. that would be an example of an alert. I observed that ice fishing attack on a transaction. And labels are more durable statements about entities. For instance, a bot could say, hey, that address that is engaged in ice fishing, I want to label that as a scammer. And that is more of a durable statement about entities. And so that's a high level difference between alerts and labels. So what I want to do right now is essentially develop and deploy a detection bot that alerts when a stolen NFT is transferred to a scammer and label that NFT as stolen. Now, you may ask the question, well, why do we want to create a feed like that? Right now, if somebody steals NFTs, they can just trade them anywhere, right? There's very little friction to essentially sell stolen goods. But you could think about, what if we have this threat intelligence about all stolen NFTs out there?
Wait, so if we already know the NFT was stolen,
yes,
and we're going to label it the NFT as stolen, why wouldn't we already have it labeled as stolen?
Oh, we don't necessarily have it labeled as stolen. We basically, what we know is that an NFT is being transferred to a known scammer.
Got it.
We're making the assumption that if this address is known as a scammer, we're making the assumption that every NFT that gets sent to that scammer is actually a stolen NFT.
Got it.
And so when you then have kind of this threat intelligence about all these stolen NFTs, if that gets then distributed for NFT marketplaces, for wallets, there's an opportunity to create friction for the scammers, make it harder to sell the stolen NFTs, and that hopefully has a negative impact on their business model.
Sure. So there's a labeled scammer. There's a labeled address that's labeled as scammer. They get transferred to an NFT, and we want to now label that NFT as stolen, and then also create the alert that, got it, makes sense. Also create the alert that the NFT was likely stolen. Okay.
That's exactly right. So the process of the bot is we will listen to transactions that come in. We will filter for transactions that essentially represents a NFT transfer. We will look at where the NFT is being transferred to. At that point in time, we will query essentially the Forta labeling system to ask the question, is this address a known scammer? And if that condition holds true, then we'll label and emit the alert accordingly. All right, let's just look at a transaction here real quick. So here we essentially have it's essentially a fraudulent NFT order. Right?
Yo, what is that plugin? Transaction explanation.
This is a MetaBlock from a BlockSec team. Great plugin.
What's it called?
MetaDoc, sorry.
MetaDoc?
Yes.
It's a Chrome extension?
Yeah, it's a Chrome extension. It really does magic on Block Explorer with additional context and additional labels and tool integration.
Holy shit, that's cool.
So here, essentially, we have a fraudulent NFT ordered on the Blur marketplace, where essentially a scammer is buying 5 NFTs for 0 ETH. And so now if we look at the logs, we essentially see the transfer event, right? It is going from aidencarl.eth to the fake fisher. We got the token ID 628. And then, of course, we have the address, which corresponds to the NFT token contract. And so essentially, when the bot receives a transaction, it needs to filter the transaction for these log events, extract that information, query the labeling system, and then emit an alert. And that's what we're going to do now in the bot that we're going to develop.
Great.
So in order to get started, I'm not going to go through a setup process, but there's a few things that you need. Node.js. I'm going to develop the bot in Python because I don't know any JavaScript. But if you know JavaScript and TypeScript, you're more than welcome to develop it in that language as well.
Python is the correct choice.
Then you need a Docker, because what a Docker is essentially being used to package your bot into a Docker container. And then the Docker container is being uploaded onto IPFS. And that's essentially the location where the scan node will pick your bot from, your bot code. That's essentially what it's going to deploy.
Oh, this brings up an interesting question. Is my node also an IPFS node? do I have to pin the bot?
It is not an IPFS node. It talks to the IPFS system in order to download my.
So the reason that I asked though, so IPFS doesn't have data persistence, right? Somebody has to manually say, I'm going to pin this data out of the goodness of my heart. What's that process look like? So when I create my bot, I just pin it, and then as I guess nodes in the Forta network, we probably should also be IPFS nodes. How does that work?
Yeah, that's a good question, and it's a little bit outside my comfort zone. I understand when I, as a bot developer, when I publish a bot, it basically creates a Docker container, uploads that Docker container to IPFS, registers the bot with the smart contract of the Forta protocol, and then that bot gets assigned to a scan node. The scan node will look up the IPFS record, download the Docker container from there, and run it.
Got it. Maybe that's a future improvement thing where it's like, hey, all Forta nodes should probably also pin all the bots so that we don't lose them. The Forta Foundation right now is probably pinning them all, or that would be my guess, just to make sure. But interesting. That's cool.
Yeah, that's a good question. I'm curious myself now. Then you need some Matic, and this is primarily in order to essentially interact with the Forta protocol smart contracts. And then you also will need some Fort, because once you have published your bot, you will need to stake it before it is in a runnable state. And we'll go through all of that as we publish a bot and stake it. So then there's an SDK. And essentially, once you set up your development environment, you run this particular command. Instead of TypeScript, you use Python. And what that will do is essentially skeleton project. And let's jump into the project. So this is essentially what I've done here. Basically, just initialized it. And so it has.
So this is just running that one command line. You get all of this just from running that one command line. Can you walk me through what was created? Like, so everything on the left here is what it created. So so let's walk through this. So PyTest cache, obviously, whatever, .vs Code, whatever, node. If I'm using Python, why do I need node modules?
I think the reason, again, a little bit outside my comfort zone, but I understand that the SDK is natively in JavaScript and Python is essentially a wrapper.
It's okay. Fair enough. Okay. So SRC, I figure that's where the actual bot is. Cool, makes sense. Docker stuff, Git stuff, Docker stuff, license, the JavaScript stuff, PyTest stuff. Okay, cool. The rest of it makes sense. Let me, hold on. You wanted to say, hey, what we see on the left here is the boilerplate code for getting started with it. Forta detection bots are JavaScript bots, and we are using Python as a wrapper, like exactly what you just said. Just like real briefly summarize what you on the left.
So when you initialize the project with the command that I have just shown, it will download this code. This is boilerplate code. In this instance, I have initialized the project with Python. And Python is essentially the Python SDK is a wrapper around the JavaScript SDK. That's why you see node modules and some JavaScript snippets, but we will develop everything in Python from now going forward. And on the left here, let me just go through some of the main files. So the package.json essentially describe your bot. It captures things like the name, the version.
Can you click on it?
The redundancy, what chain it is deployed on. So those are kind of things that you define in the top section right here. README is pretty explanatory, but this README will also then be packaged up into the Docker container, and that's something that then is being exposed on the Forta Explorer. The Forta Explorer is essentially the UI that allows you to explore bots. And let me just show this right here. So this is the Forta Explorer. You can go to the bot search page and search for a variety of bots. So here we have the scam detector feed. Here you have a link essentially to the GitHub repo. This is coming from the package.json. And then
so hold on. So this Forta Explorer, this has a bunch of bots. This has all the bots that are registered.
That's right. So you can explore and hey, I'm interested in scam, I'm interested in exploits. And so it has keyword search and allows you to find other bots. And I think that's very important if you want to build on top of other bots as opposed to reinventing the wheel, as we're going to do with this example.
Cool. So after this demo, will we see it, our bot, live on the Explorer?
Absolutely.
Yes. Okay, cool.
All right, so this bot here is a very simple bot. It essentially does a boilerplate code, essentially just monitors for large tether transfers. And
are we gonna change this so that it's the stolen NFT?
That's right. We're going to change it. But let me kind of show a little bit the command line interface that allows you to test essentially the bot. So in the command line interface, you can run the bot against a specific transaction. So here in the README, we have a large tether transfer. So what that allows me to do is essentially run the bot against that particular transaction, which is great for testing purposes against a real transaction on the network. The other thing that you can run is, of course, the unit tests. And then lastly, you can run against the live network. So now what essentially is happening as blocks are getting mined, transactions are then forwarded to the detection bot that I'm running now locally on the machine, and then its logic runs. And so as you see here, there was a large tether transfer. So these are functions that I use daily as I develop bots to really test them locally before we deploy them onto the network.
I'm assuming you're using some environment variables here.
There are some environment variables like the RPC endpoint, but that is, I think, really the only environment variable.
That's the only one. Okay. Is that in the README somewhere that you need an RPC environment variable?
Yes. In the quick start, as you set up your bot, it describes how you capture your key essentially. Because eventually when you publish the bot, you need to register it against the smart contract, you need to sign a transaction. The Forta config contains that information, and in that config is also the RPC endpoint.
So did we already do the init command will initialize the Forta, blah, blah, blah. So how come we don't see that file in your VS Code here?
The reason, because it's a global file, it's like one time you set it up
okay.
The development environment.
Got it. So in there you have an RPC, maybe some other stuff. Cool.
Okay, so let's do the stolen NFT. But assuming your development environment is set up, you initialize the bot, and now we can essentially start changing the bot. The first thing that I usually do is capture what I want to do in the README. And what that does for me, it just creates a lot of clarity in terms of what the code needs to do and what I'm planning to essentially output in terms of alerts and labels. This bot will essentially raise an alert, set a label whenever a NFT is transferred to a known scammer. And right now, we're just going to deploy it on Ethereum. Later on, we may want to deploy it on other chains as well. And that, again, to just inform where that is being set, that's in the package JSON, where you essentially specify the chain IDs. Forta currently supports 7 EVM-compatible chains: Mainnet, Arbitrum, Optimism, Polygon, Phantom, Avalanche, and Binance. All right, and then we want to emit a alert, essentially stolen. We call it potentially stolen. And what I'm specifying here is essentially we refer to as the alert ID. Think of it as like a unique identifier that is associated with specific logic in your bot. So a bot could have multiple paths on how to process a transaction, right? One path could be to identify potentially stolen NFTs. Another path could be identifying ice fishing behavior, right? And so you're able to essentially segregate the alerts based on these paths by the alert ID that you specify. Okay, and then we will set the severity and the type right now to info. It is more informational. And then in the metadata, we may want to specify the actual scammer that the NFT is being transferred to.
Could a Forta bot perform some action? Let's say transaction is going to do transaction like sets up for an attack. Could the Forta bot then hit like a pause functionality or something?
So the Forta bot, not directly. However, OpenZeppelin's Defender product integrates with Forta, and you can configure exactly what you talked about. If alert XYZ is received, then the Open Zeppelin Defender system could pause a smart contract.
Cool. Although hypothetically, the bot could do it too. I would just need to give the bot like a weird public-private key, but that's probably undesirable for other reasons.
That's right, because you have to think about that the bot code, of course, is
public,
public as it is resides in IPFS.
Makes sense.
Okay, so then we have the alert defined, and I just pasted in here the transaction, which is essentially the transaction that we looked at. I know that the scammer here, the fake phishing 76183, is already known to be a scammer in the Forta system. And so if I run this particular transaction against this particular bot, what we should be seeing is an alert. All right. So then a boilerplate template, as I mentioned, that initially gets sized, is actually quite helpful because it essentially the logic is very similar. It monitors for tether transfers. And so here what we're really trying to do is we're trying to monitor for NFT transfers. And so we will essentially just modify the ABI here to match the transfer signature for NFTs. And actually, let me copy and paste that. So then let's go through what happens. So we have the handle transaction function, and this is the function that the bot needs to implement. As I mentioned, a bot can receive a transaction, it can receive or an alert from another bot. And so right now we're essentially implementing handle transaction. And with that, we get a transaction event passed in. So these are transactions, of course, that are already mined. So we have all the information, right? Has it been successful? All the logs associated with the execution of the transaction that is essentially available to us. And then what we return from this function is an array of findings, which is really just another word for alerts. And the finding object essentially contains all the information associated with the alert. So it has a name, it has a description, the alert ID that I mentioned, severity, and type, as well as metadata. And let me jump into the Forta Explorer so you can see what the alerts actually look like from a bot. So here we have the scam detector bot, and I'm just randomly picking one bot. And here is essentially a list of all the alerts that it has emitted. And so when we click on a particular alert, now we essentially see the same fields that correspond to the findings object that we just saw in the code. So we see here essentially the title, the description, we see the alert ID, we see the severity, and then when we scroll down a little bit, we see kind of metadata field, which is just a dictionary of whatever you feel like is good additional information to convey with your particular alert. And so this is essentially what we're going to set here in the handle transaction event.
Can you scroll all the way to the bottom? Okay, cool. So if you want to scroll back up, actually. So the main function that we're working with is basically this handle. Sorry, can you scroll back up? What's this function called? Handle transaction.
Yeah.
Handle transaction. Okay, so it takes a transaction. So basically, every single transaction is going to get passed through this function. And this function is going to go, okay, cool, I got the transaction. Let me look for this stuff that I'm detecting for, and I'm going to output this array of findings. Okay, makes sense. So every single transaction in a block is going to get passed through this function.
That's correct.
Gotcha. What happens with chains where there's a lot of transactions very quickly? Is this run in parallel? Can it be run in parallel? This is a little bit of a lower level question.
Excellent question. As Andy explained, when you deploy a bot, it gets there's some redundancy, and the bot gets deployed, let's say, on 6 scam nodes. But what that means, these are identical copies, instances essentially, that receive every single transaction. And you are correct. Depending on how much processing you do within your code here, your bot may be too slow and is not able to keep up with transactions that come in. And so what you're able to do on the Forta network is introduce sharding. where essentially you split up the bot based on kind of the number of shards that you configure. So let's assume I have 2 shards. That means 50%. So then that results in 2 instances of the bot on different shards. And it essentially means that half of the transactions get sent to the first instance of the bot and half of the transactions to the second instance.
Interesting.
That really allows you to distribute the load.
Interesting. And then if I wanted to, I could code this as a Pythonista myself. I could use asyncio or do multi-threading. And then obviously the requirements for the node would change. Or
well, you're running in a Docker container, so you have a lot of leeway. And even some bots out there that get a transaction, then they spin up a Ganache to essentially fork the chain at that point and then start simulating.
Right.
And so all of that is really happening outside of your Python.
So when I get this list of findings, where do I report it to?
So the findings, essentially, you just return from the handled transaction.
But where does it go? Like, how does the Forta Explorer, am I writing this to the smart contract? Am I sending a transaction on chain?
So again, a little bit outside my wheelhouse, but the way I understand is that the transactions, the findings get packaged up in a package of many findings that then get signed by the scan node, and then that signature gets submitted on chain. But then the actual findings are being sent to a Forta component.
A what?
A Forta component. But I'm a little bit hand-wavy exactly how that works.
So there's
provenance around, hey, this particular scan node had this instance of the bot scanning this particular transaction, and it led to that finding.
So there's, sorry, let me just see if I get this. So there's a little bit of, there's a process we don't fully understand yet. So when my bot finds something, it goes, yo, I found somebody. I got to tell somebody, question mark, it shows up on the Forta Explorer. So we're signing this finding. It's not getting published on chain. I feel like that would be
not the entire finding. The entire finding is not published on chain because that would be way too
expensive. That would suck.
Given kind of the data, but it gets packaged together, and then the node signs that particular package, and the evidence that the signature is submitted on chain. So essentially, there's a whole package of 1,000 findings, and you can tie the signature to evidence on chain.
Got it. So there's some process of them signing and sending a transaction that got it. So the node goes, oh, I found an alert. I'm going to tell the smart contract, but I'm not going to tell it everything. I'm just going to, got it. Okay. Interesting. I'd be curious to see what that exactly looks like, but fair enough. Cool.
Okay. So then if we look at the code here, essentially we want to get the transfer events. And so we're going to filter. So the transaction event has essentially all the logs, and there's a filter log function on here that allows me to essentially filter for ERC 721 transfer events. And then that is essentially available for me to further analyze. Oops. So we're going to essentially iterate through the transfer events. And what we first want to get is the token contract address, which is in the address field. Then the to address, this is essentially the potential scammer, right? The NFT is being transferred to somebody, and our logic in the contract would be, hey, we want to raise an alert if that to address is a scammer. The from address is really not that right now, in that it essentially is potentially a victim or maybe another scammer. And then lastly, we want to get the token ID, because that's essentially what we want to report. So then essentially we need to first assess whether the to address is a scammer. And so we'll have a function around that.
Is there a function built in with Forta called isScammer?
No, we will implement that.
Oh, okay.
So then we will, if it is a scammer, then we'll essentially emit an alert. And we'll be quite descriptive here. We basically say NFT token ID was transferred to a potential scammer. And let's also add the contract address.
Hey, Christian, make sure you throw an O in there for the name, potentially.
Thank you. Thank you.
That was my value add to this.
And then we'll have the alert ID, potentially stolen NFT transfer. That we'll copy in here. We have the severity to info, findings type to info, and then we'll put the scammer address into the metadata. And that is essentially it. And when you think about the main function,
and then
right?
we'd want is scammer to take in potential scammer instead of two.
That is right. Thank you.
Yeah, all good.
So we still need to implement that.
Type hints, excellent, love it. As I've gotten so used to doing type hints, I was reading these functions and I was like, don't say anything. It's fine. It's fine.
Yeah, no, the boilerplate, unfortunately, it does not do it.
A lot of beginner Python engineers actually get confused by type hints. So it's, yeah.
I get confused if it doesn't have a type.
Yeah, same. Yeah, I'm the same. I'm like, I don't know what this is. I don't know what's going on.
All right, so what I pulled up here is essentially the documentation around how I can obtain labels from the Forta system. So there is a function called get labels. And what I need to essentially pass into that function is, first of all, the entity that I'm querying about. So this would be essentially the potential scammer address. Now there is hundreds of bots deployed on the Forta network, and they can say whatever they want, right? They can call every single address a scammer. But I want to really only trust labels from a particular bot, the scam detector bot. And so when I query the labels, I can essentially say, give me only the labels for that particular address from the scam detector bot that I know and trust. And so in order for that to happen, we need to find out essentially the bot ID of the scam detector. And this is the scam detector that I want. And essentially, we have the bot ID right up here. So then when I query get labels, I basically say, hey, only give me the labels from this particular bot. All right, so here we have the scam detector bot. And then I'm going to call labels, which I haven't imported yet. Get labels, and it takes a dictionary of source IDs. So this is essentially an array of the bot IDs that I want to query. Then I want the entities, which is essentially an array of all the entities that I want to query. And then lastly, I need to set the state variable. And this, I know it's not a great name, but this is essentially, okay, so let me explain what state is for labels. Labels essentially get added by bots. And think of a bot can say, hey, I'm going to label this entity, and then later on, I'm going to label it again. And then maybe, oh, it's a false positive, and now I want to remove the label. And so if you have state set to false, you see all the different events. Whereas if you have set state equals to true, then it kind of consolidates that information into one ground truth. So if a label was added and later removed, then you wouldn't see it in this particular query, because it's really just a resolved state. So that is, hang on, so get labels, there we go. And so then that gives me the label response, and there could, of course, be multiple labels. It will be exposed in the labels variable that I'll iterate over, and then basically I will say if scammer in labeled, sorry for many labels here, I will return true, and otherwise I will return false. And I think that is essentially the core of the bot. And so now, since we have had a transaction that we can test again, let's see what happens. So now essentially it pulls up the transactions from the network, and then it will run our logic. It will see essentially the log. Let me just pull that up on the block explorer here. We see the log with approvals and transfers. It filters out the log for all NFT transfers. It then extracts the information like the NFT token ID, the contract address, who it is being sent to. It will check every address that is being sent to assess whether it is a scammer. And if it is a scammer, then it will emit this particular alert. So now essentially we have a bot. Now, one thing that we probably want to do is run it against the live chain. And the reason why I generally do that is just to weed out additional errors. There may be some parsing oddities. And so it's good to just run it for a few minutes against the live chain to make sure that it does not throw an error. And also, if you think about threat detection, running it against the live chain gives you an initial indicator on how noisy the bot potentially is. It's, of course, not the whole assessment that we would make, but it's kind of like an initial indicator. Okay, so that actually looks pretty good. So now we have the bot coded up. Now I would, of course, add unit tests here as well, but for the purpose right now, let's skip over that and move towards a bot deployment. So in order to deploy the bot, you essentially run npm run publish. And now what essentially happens is the code gets packaged up into a Docker container. And then that Docker container gets uploaded to IPFS. And then the bot is being registered with the Forta protocol.
Where's the IPFS node running? Do I have to, am I using, again, like a Pinata type service? Am I running my own node? How does it know where to push a type?
I believe it is a FS node that is run by the Forta Foundation, but I'm not 100% sure. Okay. But it is configured automatically when you set up the dev environment.
Got it. Okay. I'm assuming it's in that config, that Forta config that we were talking about. I'm just going to assume there's a lot of magic environment variables in there.
Yeah, let me just...
yeah, I was going to say, don't show me on screen just in case. But yeah, or maybe it's hard-coded in there, like the IPFS endpoint for the Forta Foundation could be hard-coded somewhere.
I don't see it in the... Oh, actually, there is IPFS gateway URL. And so it's ipfs.forta.network.
Got it. Okay. So you could upload it to your own IPFS node if you wanted to.
Okay. Yeah, let me actually should enter the right password. That didn't work. So let's just do it again.
It's all good.
Okay, so now it essentially signs the transaction and adds the bot to the registry. And so now what it also gave you is this bot ID. And so this is going to be important to then pull up the bot on the Forta Explorer to then essentially stake. So let's go to the...
Oh, so we haven't staked yet.
No, we haven't staked yet. So basically what we'll see, we'll see the bot here in a second. So it's still not...
Right, yeah, it's indexing, yep.
It's going to be fairly quick. And then basically what we will see here is that it has no active stake and that node operators is essentially 0, meaning, hey, it's not staked, therefore it's not enabled, and therefore it doesn't get distributed to scale node operators. So essentially what we need to do is just stake it now that we have deployed it or published it, and then it will get pushed onto the node operators. And oops. We'll go to the Forta app. I'm already signed in. There's going to be essentially my detection bots. And so there's a whole bunch of detection bots there's the detection bot that I just deployed.
Nice.
Bot ID. Now we go in and, oops, come on.
We don't actually have to stake, but because this is the last step, right? Or you can go to stake. That's cool too.
Yeah, no, I think it's... What I think is really neat about the whole process is that how long have we been coding here? Half an hour coding, and in 5 minutes, we will essentially have it deployed, staked, and running on the network.
Love it.
So now I'm just approving 100 Fort. 100 Fort is the minimum amount of stake that you require. So I just approved that. Now I have to actually stake it. Now we go back to the bot. We can refresh that here. It says active stake. And then in a few seconds, this disabled will move into an enabled state. And then it will show as running on the network. So let me actually pull up the bot that I deployed yesterday, which is essentially the same logic. And then essentially it will look something like that. Enabled, active state of 100. And now we're running on 3 nodes.
Very cool.
This is the default redundancy. We see down here that essentially it has found a few stolen NFTs. One thing that you're able to do is, of course, with the Block Explorer or the Forta Explorer is to then jump into the evidence associated with the alert. So the bot operated on a transaction. And here, essentially, we have the transaction ID, right? And so now if we pull that up in Etherscan and we look at the logs, we will actually see the transfer event. So there was this Cookie Pixelverse NFT 7083 from this address to this address, and this is likely to be a known scammer.
Right.
So if we pull that one up, we should see that it has been identified as a scammer.
Very cool.
There we go.
Cool. So this whole process that we went through of creating a bot. So we spent a little bit of Matic to
Yes.
we spent a little bit of Matic to deploy this bot. We staked some Fort token as well. What is my incentive to go through all this work? How do I get paid as a bot developer?
Andy, you want to take that one?
Sure. Yeah. Incentives are important. So there are upcoming, I think the incentives get really interesting for bot developers. So for the first 18 months of the network until today, everything's been free, right? So you publish a bot, there hasn't been a way for you to monetize it, despite there not being that kind of sticky monetary incentive. We've still had teams and individuals deploy really valuable things just to be helpful to the community. Post-August this year, bot devs will be able to directly monetize their creations. And we've got 2 kind of buckets of bots that will exist. There is a general bucket, which is where 99% of the bots will live, and anyone can get access to the intelligence generated by the general bucket of bots for $100 a month flat fee. The second category of bots are what we call premium data feeds, and things like the scam detector. Christian's stolen NFT bot here might qualify for that in the future. And for that category of bots, the developer gets to set their own price. So you can price it at $10 a month. You can price it at $10,000 a month. A market will decide whether it values that. So we're really excited about this post-August 1st because it'll be the first opportunity for a lot of the individuals and teams that have built valuable things on the network to actually start seeing some gains from that work.
Interesting. Cool. Very cool. Yeah. And thanks, Christian, for bringing us all the way to the aha moment. That was great. Yeah. No, guys, this was fantastic. I don't have any other questions. To me, this is something where I'd want to jump in and start playing with it. Now that I've been doing a lot of audits and stuff, the auditor in me goes, oh, how can I break this? Which is why I was asking questions about, hey, can I deploy malicious bots? Especially now that there's a monetary incentive coming. A part of me is ooh, okay, how do I break the network? How do I scam the network to make a whole bunch of dough? I'm going to be really curious to see how this evolves moving forward. Like we were talking about before, monitoring is something that we do a pretty terrible job of in Web3 right now. Yeah, I don't have any other questions. I think most of this is pretty much clear. It sounds like there's a bunch of stuff that the Forta Foundation is working on to improve it, which is awesome. Yeah, I don't have any questions. Is there anything else that you guys want to add?
No, just that we hope we see some of your viewers on the network over the next couple months.
Definitely. Cool. Christian and Andy, thank you both so much for being here. This was a phenomenal workshop. Thank you all so much for coming. And I hope to see the rest of the community also build more bots and keep the Web3 ecosystem safe.
Thanks so much, Patrick.